Welcome to the third lesson in my series on the geometry of the circle at higher mathematics level. And we're going to look at the general equation of a circle. That really means we're going to take the equation that we've worked with in the previous two lessons, which you can see on the screen now, and we're going to look at breaking those brackets. We're going to expand that equation. So to do that, let's look at an example circle. So let's look at x minus 2 all squared plus, let's go for y plus 3 all squared. And that could equal 25. So this, of course, is the equation of a circle. And we know that we can find the center fairly easily, center being 2, negative 3. And the radius of that circle would be 25. So that's very easy to do in that form. But there are reasons why we might want to expand the equation of a circle. So we're going to look at an example where we do that here. If we break the brackets, we have x squared minus 4x plus 4. And breaking the second bracket, we have y squared, 3y plus 3y would be 6y, plus 9, and that equals 25. We're just going to group together the x squared and y squared terms. So that would be x squared plus y squared. Then we've got our take away 4x plus 6y. And just being careful with the constant term, we've got 4. On the left-hand side here, and we've also got 9. 4 and 9 is 13, and we want to subtract 25 so that the constant term appears on the left-hand side of the equation. So that would be take away 12 equals 0. So that's really just breaking the brackets on the equation of the circle. And this is what we call the general equation of a circle. It's really the expanded form. You need to be able to do that for a given circle, and you also need to be able to reverse that process, or certainly to take the equation in this form and determine the center and the radius. So we'll look at doing those in this lesson, but let's just be clear that all we're looking at is the expanded form of the circle. The first question then would be, could we still identify the radius, and could we identify the center? Well, the second of those is easier. If we look at the center, we can see that we could actually still pick out the center. If we look at negative 4x, we know that that comes from breaking the bracket. We know that that means the bracket would have been x minus 2. So we know that the center is 2, and then for the y coordinate, it must be negative 3. So actually we're halving that coefficient of x and changing the sign, halving that coefficient of y and changing the sign. And that's going to be something that we'll look at in this particular lesson. So the answer here was just 2, negative 3, which makes sense. It matches what we had before. How would we find the radius in this form? Well, that's a little bit more difficult. So there are two ways to do that. One would be to reverse the process, which would actually be to complete the square, and we'll look at that. Another way would be to use a formula that we have for the radius of the circle. So we're going to change notation slightly here, and this expanded form can be written as x squared plus y squared plus 2gx plus 2fy plus c equals 0. G, f, and c are just constants, and we recognize here that this is a way to look at how to find the center of a circle in this form. We know that we have to half that coefficient of x and flip the sign. So the center in this form would be negative g, negative f. We'll see that in practice in some examples. The radius is a bit more complicated. We use a formula to find the radius, and it's important that g squared plus f squared minus c that you see in the square root is positive, greater than 0. Let's look at a quick proof as to why this is actually the equation of a circle. So you can see here we've got the equation, the general equation that we're going to work with. This is the one that you'd be given in a formula sheet. And I'm just going to group the x terms together and group the y terms together. So really we're going to complete the square and reverse the process here. We'll move the c to the right-hand side, so it'll become negative c. Now, x squared plus 2gx, if we complete the square on that, we can see that that could be x plus a half of the coefficient of x, and that'll just be g, so x plus g all squared. But that will give me a plus g squared that I don't want, so we'll take that away. And similarly, we can complete the square on the y term. You may need to brush up on your completing of the square. And that equals negative c. So first of all, we grouped the terms together. Now we completed the square. Here, I'm just going to group together the x plus g all squared and the y plus f all squared. And I'm going to move all the constant terms to the right-hand side. So that will be g squared plus f squared minus c. And now we're back to the form that we had in the first two lessons. You can see this is the equation of a circle, where the center would be negative g, negative f. And the radius would be the square root of the term on the right-hand side of the equation. So the radius would indeed be the square root of g squared plus f squared minus c. And that's why it's important that that term on the right is positive. We cannot square root a negative in higher maths. So it would not represent a circle if that was not the case. In our first example, we'll look at how to find the radius and the center of some circles. We're going to use, of course, this general equation form. So if we just remind ourselves that in general, that would be x squared plus y squared plus 2g multiplied by x plus 2f multiplied by y plus c equals 0. So both these equations are in that form. And when they're in that form, the center would be negative g, negative f. And the radius, we need to use a formula to find. That would be the square root of g squared plus f squared minus c. So let's look at the first example, example A. And really by inspection, we should be able to work out the center of the circle. So we talked about the idea that this is still possible fairly easily. So we're focusing on the coefficient of x. That would be the 6. That's 2g. G would be 3. So negative g would be negative 3. So the center here is negative 3. And equally, by looking at the y coefficient, we half it and change the sign. It would be 1. So the center is just negative 3, 1. To find the radius, we need to use the formula. So that can be a bit more complicated. We just have to take care. The radius would equal the square root of, and it's going to be g squared. Well, g would just be 3, so 3 squared, plus negative 1 squared, take away 1. And of course, that's just the square root of, that would be 9, plus 1, take away 1, which is really just the square root of 9, so it's just 3. So we have the center, we have the radius from the general equation. Now looking at example 1b, an alternative approach here would be to complete the square, to reverse the process of expanding the circle. So we can try that for this particular question. So I'm just going to group the x terms together, group the y terms together, and move the constant term to the right-hand side of the equation. So we've got plus 4. Then I'm going to complete the square here. That's x minus 4 all squared, but we have to compensate by taking away 16. And same for the y terms. We've got y minus 5 all squared, but we must take away the 25 that we don't need, and that equals 4. So this is one option that we could use, although it's not always easy to do it this way, but usually we can. And here we have x minus 4 all squared plus y minus 5 all squared. We move the 41 to the right-hand side, it becomes 45. So by completing the square, by rearranging the equation, we can find the center to be 4, 5. And the radius, of course, is the square root of 45, which is a third. So that's root 9 root 5, or 3 root 5. Which is easier? Well, I'll let you decide. You should really be fluent in both methods. We could have used the general equation and used the radius formula, or we can complete the square. In example 2, we're going to be given some information. In this case, the point 2, negative 3 lies on the circumference of a circle, and the center of that circle is 2, 4. What we need to do is find the general equation of the circle. Now, there is actually a way to do this by finding the radius, which would just be the distance from that point to the center. That would actually be quite a simple way of doing it. But another way would be to write down the general equation, just to get some practice with this idea. Although this might be a slightly longer way to find the equation. So there's the general equation of the circle. We could substitute each point in. Let's do that one at a time. So we'll start by substituting in the center. So the point 2, 4. So we know that that relates to G and F. That 2, 4 is really just negative G, negative F. So we've got to be careful here. Substitute one point at a time. X squared plus y squared. So if 2 is negative G, then G is really negative 2. So that's 2 lots of negative 2 times x, and 2 lots of negative 4 times y, plus c must equal 0. I'm really doing this to find the value of c in order to have the equation of the circle. We've got the values of g and f already. So having done that, we end up with negative 4x and negative 8y, plus c equals 0. So we nearly have the equation. To find c, of course, we can substitute any point that's on the circumference of the circle. Here we have a point 2, negative 3. So we can substitute that point in. So 2 squared plus negative 3 squared. Take away 4 lots of 2. Take away 8 lots of negative 3. Plus c must equal 0. And if we solve this for c, we have the general equation of our circle. So we've got 4 plus 9 minus 8 plus 24. Plus c equals 0. We'll see that we now have 20. So 4 plus 3 is 4 plus 9 is 13. Yeah, we've got 29. Plus c equals 0. C must be just negative 29. And if c is negative 29, then we have the equation of this circle as x squared plus y squared. Take away 4x, take away 8y, and then take away 29 equals 0. So that's another way to find the general equation, although there was a simpler way by finding the radius, by looking at the distance between the point and the center. Our final example, we're going to look at why a particular equation that we're given might not be the equation of a circle. So we have to explain why this equation does not represent a circle. Now, if we look at the equation, we might immediately see that if it were a circle, the center would just be the point 4, negative 1. So the center is not the problem. The issue arises around the definition of the equation of a circle in the general form. So we know that the equation of a circle was x squared plus y squared plus 2gx plus 2fy plus c equals 0. But that was only if the radius, which was the square root of g squared plus f squared minus c, that was only if that value was greater than 0. If it's not greater than 0, then it can't be a circle. The radius would have to be positive value bigger than 0. So really this is what we're focusing on in this example. We have to show, if it's not a circle, that the radius doesn't exist. So we find the radius for this particular question. That will be the square root of, now g here would be negative 4. So that would be negative 4 squared plus negative 1 squared. And plus 1 squared, and take away 20. So that would be the square root of 16 plus 1 minus 20. Here we have the answer, square root negative 3. That's not possible at higher math level. We can't take the square root of a negative value at the moment. So the answer means that actually this is not a circle. We would say something like, as g squared plus f squared minus c is less than 0, it does not represent a circle. So watch out for those kind of questions in your practice. Okay, it's now over to you to get some practice with the general equation of a circle. If you're studying the TG textbook, then you want to go to page 79, and that exercise has some really good questions, a couple that are particularly challenging, so that'll be very good practice. Similarly, if you're studying Heinemann, then there will also be some excellent questions on pages 218 to 220 of exercise 12H. It's really important you get that opportunity to practice, as you're now sort of more than halfway through this particular topic, and you must get some expertise in identifying the center and the radius of a circle, moving between the forms and solving some geometry problems. Do check out the rest of the lessons though when you're ready. Until then, take it easy.